Hey guys, it's Miss Johnson and I'm here to bring you your second notes video for chapter 12. Today we're talking about permutations and combinations and what are those things and how do we find them. The first example up at the top of your notes page says when a manager of a softball team fills out her team's lineup card before the game, the order in which she fills in the names is important because it determines the order in which the players will bat. It's their batting order. Suppose she has 7 possible players in mind for the top 4 spots in the lineup. Using the fundamental counting principle, how many ways can she assign the top 4 players? So if we think about there being 4 spots that she's assigning these people, and she's got 7 people to choose from, that means she's got 7 people to pick from in the first slot. After she fills that first slot, she only has 6 people left to fill the second. After she fills that slot, then she has 5 people left to fill the third, then 4 people for the fourth. And the fundamental counting principle tells us that we can multiply those options together to get a total of 840 different ways that she can arrange those 4 players or those 7 players into the top 4 spots. Now, this is something that we call a permutation. A permutation is when a group of objects or people are arranged in a certain order. That arrangement is called a permutation. So order is important. This is the thing for us to keep in mind. Order is important. AB is different than BA. Even though they contain the same letters, they're in a different order, which makes a difference. Now this is an important formula to write down or that to take note of. Maybe you highlight it on your notes sheet. This P stands for the permutation. N is the number of objects you have. And R is the number of objects you're choosing. So that's what all that notation means. So the permutation of N objects taken R at a time is equal to N factorial divided by N minus R in parentheses factorial. And let's just review that word factorial. Hopefully you've heard that word before, but it may have been a while. We haven't used it a whole lot this year. If I was thinking of 7 factorial, that little exclamation point is the word factorial. And what it means is that we multiply the integers from that number down to 1. So 7 times 6 times 5 times 4 times 3 times 2 times 1, which in that case gives us 5,040. So 7 factorial is actually equal to 5,040. It doesn't mean that we really like the number 7, where we think 7, like we're really excited about it. That exclamation point actually has a mathematical definition to it. So let's just do some examples. In number 1, it says there are 10 finalists in a figure skating competition. How many ways can gold, silver, and bronze medals be awarded? So what we want to consider is how many people are there and how many people, we're going to get rid of this stuff, how many people are there and how many people are we choosing? In this case, we have a total of 10 finalists. That's our N. That's how many objects or how many people we have. The number of people that we're choosing or that we're going to use, one person's going to get a gold medal, one person's going to get a silver medal, and one person's going to get a bronze. That means that we're choosing 3. That's going to be our R. So we are going to end up with the permutation of 10 objects taken 3 at a time, or in other words, 10 objects, choosing 3 of them, which is equal to, and I'm just going to fill in this formula here. We have 10 factorial over 10 minus 3 factorial. Now be careful here when we simplify this out, I have 10 factorial over 7 factorial. And the thing that's nice about this is that what that gives us is 10 times 9 times 8 times 7 times 6 times 5. That's what that factorial means. All the way down to 1. In the denominator, 7 times 6 times 5 times 4 times 3 times 2 times 1. What helps us here is the fact that we know that any number divided by itself is 1. So when I'm looking at 7 divided by 7, that's going to cancel out. 6 divided by 6 is going to cancel out. 5 over 5, 4 over 4, and so on, all the way down to the 1. So what I'm really left with is just the 10 times the 9 times the 8. Now you can see that from this step right here, 10 factorial over 7 factorial, we know that 7 on down is going to go away. So all I need is the top number down to the 7, which is 10 times 9 times 8. In this case, that gives us 720. So that means there's 720 ways that we can arrange the gold, silver, and bronze metal. Now, the reason this is one that order is important is because gold is different than silver, which is different than bronze. So it does actually make a difference what metal you get and what order they're placed in. Let's take a look at number 2. In number 2, it says a newspaper has 9 reporters available to cover 4 different stories. How many ways can the reporters be assigned to cover the stories? Well, we assume that the stories are going to be different. So putting the first reporter on the first story is different than putting the first reporter on the second story, which is why, again, this means that order is important. If we have 9 total reporters, that means that's our N, and we're covering 4 stories or choosing 4 of them to cover 4 stories, that's the R. So this is going to be P, or the permutation of 9 choosing 4 at a time. That gives me 9 factorial over 9 minus 4 factorial. On the top, that's 9 factorial. In the denominator, 9 minus 4 gives me 5. That's 5 factorial. So again, what that would look like if I expanded this out is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. In the bottom, I have 5 times 4 times 3 times 2 times 1, which again, 5 over 5 cancels out, 4 over 4 is 1, 3 over 3 is 1, 2 over 2 is 1, 1 over 1 is 1, and I'm left with just 9 times 8 times 7 times 6. When I multiply those all together, I get 3,024 ways. Okay. I want you to go ahead and pause the video at this time and see if you can think of the arrangements that we can use in number 3, the word geometry. Okay. Okay, now hopefully you got a setup with that looks something like this for number 3 for the word geometry. Now there's a couple of points that I want to make about this example. One of them, the first being, when I have a denominator such as choosing all 8 of those things where I have 8 minus 8 and that gives me 0, 0 factorial is actually defined to be 1. So we know that 0 factorial is going to equal 1. That's the same thing as saying 8 factorial divided by 1, which we know doesn't make a difference. So you actually don't need to do that. So now you get an answer of 40,320. But what we also need to consider is the fact that in the word geometry, we have 2 letters that are the same. They repeat. The E repeats itself. So we have to account for the fact that switching those 2 E's is not going to make the arrangement any different. Putting an E in the spot of an E means the same thing. So I need to take that into account. And here's how I do that. I need to take the number of arrangements, which is 8 factorial, so I have 8 factorial, and I need to divide out the number of repeating letters factorial. So this is the total, and this is the repeats. So since there's 2 E's, that's where I get the 2 factorial. So when I do that, that ends up being 8 factorial divided by 2 times 1, which we all know is just 2. 8 factorial divided by 2, and that leaves me with 20,160 arrangements. So taking into account the fact that we have some repeating letters there is important for us to consider. We're going to go ahead and stop the video at this time. We'll pick up with the rest of our notes for this notes day tomorrow in class. Thanks for watching. Have a good night, and don't forget to hop back and take your Schoology quiz.